finally getting to the point where we can really formally define what a complex number actually is, right? A complex number is when we can write it in this form, a plus bi, where a and b, they are real numbers, okay? But this here is our complex number, okay? Generally, we'll write them using the letter z. That's just by convention, right? So we can write that as x plus yi. If you'd like, you can think about I as some sort of pronumeral, okay? But the important thing to take away is that when we write it in this form, all right, we actually have two components. We have what we call the real part of z, and we have the imaginary component, right, or part. Notation to represent that, well, we can say that the real part of z, and I'm going to write my z's with a little bar on the cross because you'll find that when you get z's and 2's, yeah, you're going to get them confused very easily. So that's what my z is written. The real part of z is x. Now the imaginary component, right? This whole thing is, I suppose, the imaginary part that you're adding. But when we refer to the imaginary part of z, it's just going to be the coefficient of I that you see. So when we're asking you to find that, we're asking for the real component, right? So a and b are real values, or x and y are real values. When I'm looking for the imaginary part of z, I'm looking for this value of y over here. So just some really quick questions, right? If I want to identify the real and imaginary components, all you're doing is looking at these particular values, right? The real part for this first one here, right? I've got the real part of z here. That would be 5. And so what would the imaginary component be? It would be just the coefficient that you can see, so 4, right? What about this guy? What's the real part of v? Root 6, yeah, cool. And the imaginary component, just the coefficient again, so we've got 3, right? How about this one?
It is an imaginary number.
Yeah, it is an imaginary, it is a type of imaginary unit because we've got a I there.
You have to slap a plus 0 on.
Ah, so, but hang on. What's our definition of a complex number, right? A complex number is anything that meets this criteria. You can write it as x plus yi, where x and y are real. Can I write C like this? Can I write C in this form?
No.
No?
You say, I don't know, you try. You want to say no or yes?
I don't know, like what do you think?
I don't know what the question is. I just...
So the question is, right, our definition of a complex number is that we can write it in this form here, okay? Any number I can write in this form, it is a complex number. So is there a way I can write it in this form?
0 plus 2.
If you write it as 0 plus 2i, you might be thinking, hey, that's an imaginary unit, it's kind of separate. But if you think about it, like 0 is a real number. You can write this as a complex number. It is a complex number, right? The real component is just 0. The imaginary component is just 2. Let me do one more with you, which will really be strange. What about this? What about d is equal to 7? Nice whole number there.
0i.
Right. This is, again, a complex number, which sums up that whole thing we're looking at with those diagrams. All of the numbers that we've been looking at thus far are actually complex numbers. But we're kind of expanding our knowledge of the numbers that do exist, right? Which is a bit strange, right? So d is equal to 7 plus 0i, just to confirm that really clearly. So we've got the real part of d is 7, and the imaginary component of d is just 0, okay? So all the numbers that we've looked at in the past and today fall under this idea of what complex numbers are, okay? That's our first introductory lesson.
Didn't you say every number is a real number? Because you did that circle, right? What if I did?
Oh yeah, sorry. Okay, so I'll draw it out again. So, I just drew on myself. So going back to what we had our natural numbers, we had our integers, we had our rationals. I'm running out of circle space. There's our reals, right? And so complex numbers, which we represent with the letter C, encompasses all of those. The question is, this kind of thing here, this imaginary unit, where does that fall? Well, that would fall, it's not real, is it?
No.
Right? So it falls into this set over here. So anything that is a multiple of I, we can describe as, like a multiple of the imaginary unit. We can call it imaginary, yeah? And it falls in between this kind of section over here. Well, what is a complex number?
Everything.
It's everything inside all of this. That's why we use these circles to represent what we call sets, right? A complex number is anything that falls into here.
Wow.
And if you're wondering, well, are they just going to come up with something again that,
What's around it?
encompasses again? They are constantly discovering new number systems all the time.
Wait,
So don't be surprised if in a couple of years you're looking,
You got this and this, but what about?
and what about the thing that's coming up? What about the 3D thing, right? They're discovering new number systems all the time. So don't be surprised if if they're doing 4 unit 100 years, they say, oh, we thought complex numbers was all that they were, and then they just do another circle around the whole thing again, right?
Idiots back.
I wouldn't necessarily discount that.
They're going to be calling us idiots.
So you got your planets wrong.